It's the 3rd of March, 2015, and this is episode 192. This show is intended for informational and educational purposes only. What cryptocurrency enables is new, empowering, and exciting, but we're not experts, just obsessed companions walking the road towards a more peer-to-peer future. On today's show, Charles Hoskinson connects the dots on all this stuff that we're doing in cryptocurrency with an illuminating lecture on the advent and possibilities of programmable governance. This episode of Let's Talk Bitcoin is brought to you by Shapeshift.io. With no account or sign-up required, it's the easiest way to buy or sell Bitcoin, Litecoin, Dogecoin, BitShares, Ripples, and over 17 other leading cryptocurrencies. If you run a business and want to be able to accept more than just Bitcoin without building the infrastructure to maintain all those wallets, check out the Shapeshift API. If you're a multi-crypto individual who longs to spend their NXT everywhere that Bitcoin is accepted, you're in luck with the Shapeshift Lens browser extension. If your worldview of crypto goes beyond Bitcoin, do yourself a favor and check out Shapeshift.io to instantly convert altcoins and to discover the future of cryptocurrency exchanges. Enjoy the show.
Hi, I'm Charles Hoskinson, and this is Foundations of a Programmable Society. So the purpose of this lecture is to discuss what are the pillars required to enable a fundamentally different type of society. And when I say society, I mean it in the most abstract and general sense, all the way up to governance. So the Bitcoin revolution has given us really some pillars. First, incentivized distributed databases. So really think of these as blockchains, and it turns out there's more than one architecture that's propagating. Trustless smart behavior. So you may have heard of things like Ethereum and smart contracts. And finally, tokenized infrastructure as a service. These three pillars are rapidly evolving, and they're becoming properly incentivized to a point where they can stand as a foundation for a lot of really amazing emergent properties, which we're going to discuss in this lecture. So let's start with incentivized distributed databases. Well, the first one was Bitcoin, and this came out around 2009, as many people are aware, and the database structure is a blockchain. So the basic notion is you have an immutable block that once things are in it and it's been committed to the database, nothing can change. So it's really kind of like fact-based storage. And there's special rules about who gets to add to that database. Now, initially, the only use case was to store transaction ledger, so who owns what in the network. But over time, they've modified the Bitcoin database to include the op return code, which now allows people to store arbitrary amounts of data, although very small amounts, making it the perfect place to put in hashes or other types of integrity checks and things like that. But people said, can we apply the same basic principles of decentralization and incentivization to a file storage system, but make it look much more like Dropbox or other services like that? And that's where the MadeSafe and Storage project come from. Their goal is to achieve decentralization or federation and do this in a way that allows people to store their data securely without any central actor being able to lock them out or share that with other parties. There's some other ideas as well, perhaps having application-specific storage. So Namecoin or ideas like TorrentCoin come to mind, where they say, hey, instead of having a centralized DNS system or a website that hosts all my torrent files, let's go ahead and put them on a blockchain. And let's create incentive structures specifically for those use cases. So it behaves like Bitcoin, but it's specific for a certain class of uses. And finally, we have IPFS. It stands for the Interplanetary File System, which is perhaps the most evolved of all of these storage systems, and involves merging Kademlia, Secure File System, BitTorrent, and other types of technology together to create basically a secure hash-addressed persistent web. The takeaway from this is that all of these types of systems are incentivized, rapidly evolving, and learning from each other. And the end goal is to give us places to put our data that is secure, censorship resistant, and very, very resistant to outside actors attempting to tamper with them. They require overwhelming resources. Okay, The second pillar is trustless smart behavior. So think about relationships between actors, and that can be as simple as you and me. That could be a relationship between you and a business, you and a government. In any event, let's take actors in a decentralized system and let's formalize those relationships with a programming language like the E programming lang or Solidity, and then let's encode certain behaviors. Okay, well, what can we really do with that? Well, here are some examples. We could implement an escrow service. So let's say you and me, we're trading a product, and so you want to give me some money, I want to give you a product. Well, if the product is in the physical world, it's really hard for a blockchain or some digital system to know if that's been delivered or not. So we need an escrow agent. So it would be really nice to be able to programmably define how that escrow agent can make decisions, or the ownership of digital property. This is a case where we don't need one. Spending conditions and triggers. So that would be a case of you having a wallet and being able to put locks and controls and policies on how the money of that wallet could be spent. So for example, let's say you have a Bitcoin wallet and you say, if I spend the first 10% of my money, I only need a single signature, but anything greater than that requires more than one signature. And if I'm going to liquidate the entire account, maybe 3. That's an arbitrary example. Other things like proof of solvency. So many people in the space are very familiar with Mt. Gox or other exchanges that have become insolvent. Well, it would be really nice if you could match the inputs and outputs of exchanges and make sure that coins haven't flown out, so that you know that the money you've put into an exchange is always going to be redeemable. There's a one-to-one matching. And perhaps for gambling, you can imagine fairness. Like, for example, if you go to a poker website, how do you know the other players can't see your cards, or that your cards are being fairly generated? It would be really nice to, in a trustless way, to validate that your cards are being randomly generated, and that when you see the other player's cards, it's for the first time. Trading rules are another example, where you have an exchange and you want to make sure the way you use the exchange is identical to everyone else and no one party has an advantage. And there's been some ideas about how to integrate this behavior. So some people believe it should be coupled with the blockchain, so the database itself, and other people believe that it should be disintermediated. And so Ethereum is an example of coupling, whereas Counterparty and Codius are examples of the decoupling. There's a lot of advantages and disadvantages in terms of scalability, but this is a foundational pillar. It's basically a programmable blockchain where we have the ability to define relationships, and we're limited only by our creativity and the underlying cost of execution of the smart contract. Then we have tokenized infrastructure as a service. Now this one's a slightly new concept, but it's also an old concept. So decentralized computation and bandwidth, they've been around actually for quite a bit. If you think about BitTorrent, really what you're doing is saying, I'm going to share this file with other people, and in turn, they're going to share other parts of it with me. It's a kind of a Cedar to Leecher ratio. If you think about folding at home, that was a very popular and still is a very popular program that shares computation for the purpose of protein folding. So people can leave their PlayStation 3 on, or their laptop on, or their PC on, and overnight it'll go ahead and fold proteins so that Stanford and others can use that to search for cures for cancer or other diseases. And then there's distributed grid platforms like Berkeley Inc. So there's plenty of ideas that have been floating around. With cryptocurrencies, what we've been able to do, however, is we've been able to actually tokenize these services and make them profitable via microtransactions. If you think about protein folding, you probably aren't going to make a lot of money for that because there's a lot of capacity in the network. But over time, maybe you can make a little bit of money because you have a lot of little microtransactions. If one was using credit cards or other payment mediums, unfortunately, there's just not enough. The system is too inefficient, I should say, to transact. But with cryptocurrencies, we actually can aggregate lots of little microtransactions together. In fact, we even have begun exploring the idea of creating a decentralized Internet of Things via the ADEPT project. That's IBM and Samsung together. So as a brief aside, if you think about the Internet of Things, what that really means is that you have lots of devices, toasters, toilets, refrigerators, light bulbs, door handles, and these devices, if they're digital, usually have some form of ASIC in them that was designed by an engineer. There's a single use case, but what's happening in business is that things like cell phone processors are becoming so incredibly cheap. Instead of actually just designing a special chip for a particular device, what people are doing is just putting a CPU in the device that also happens to have a bunch of other features that may not necessarily be needed, but it's cheaper just to include them than try to omit them. For example, Wi-Fi module, Bluetooth module, a GPS module, and so forth. Effectively, what that means is the devices around your house are becoming a heck of a lot smarter, and they can begin to talk to each other. However, there's significant privacy concerns and scalability concerns and issues about how these devices are going to talk to each other and how that network is going to function properly, especially considering that infrastructure tends to be a lot longer lived than things like cell phones. So IBM and Samsung are exploring how to enable the Internet of Things using blockchain-based technology and trustless smart behavior. So that's really exciting. And then finally, we can think about mesh nets. So if you think about ISPs, they're very big, they have lots of infrastructure, but what if we can take these exact same devices that are going into light bulbs and door handles and use them as relays and allow people to construct local area mesh nets that eventually connect to the backbone? And because we can tokenize things, guess what? You can actually create a micro ISP. And there's actually been some actors who are thinking about how to do this, either from developing the software for the mesh net, so that's kind of the CJDNS project, to others like Open Garden, who are exploring metering via cryptocurrencies. So these are effectively the three pillars that a programmable society requires. So what do they enable? Why do we care about these pillars? Well, first, they enable new forms of interactions. They enable a single global marketplace. And finally, I think the most exciting thing they enable is algorithmic governance. So let's go through these in order. So in terms of new forms of interactions, let's really think about what the network looks like once you have these pillars in place. You have a wonderful place for identity and reputation and revocation. Okay, and that's something that we really haven't had before. Second, if you think about projects like Open Mustard Seed, what you can do with identity and associated metadata is create a paradigm where the user is actually in complete control with how their data is shared and actually has the ability to revoke trust. So, for example, if you go to Facebook and you put pictures onto Facebook, or if you go to Google Plus and you put pictures onto Google Plus, you've now transferred them to a third party, and trust is an absolute. You trust that third party not to share those with other people. You trust that third party not to make copies, and if you ever delete your account, you trust that third party to delete the copies of that picture. More personally, let's say that you go ahead and have a relationship, and you send pictures to your significant other, and then the relationship ends. Maybe you want to be able to revoke access to those pictures. So this is an example of something we really can't currently do with the internet, but with these three pillars and projects like OMS, it may become possible to actually revoke access to data that we've shared and also use a reputation system to enforce better behavior amongst actors in the system. So a couple of other things that are really exciting are the notion of a password-free internet. If you think about having accounts with blockchain-based technology, most of the spending rights, if not all, for altcoins and Bitcoin require public-private key pairs. And so what Bitcoin, Ethereum, and other platforms have effectively done is they've created a nice distribution mechanism for cryptographic credentials. Now, we can attach identities to those credentials, and that probably will happen. But the minute that that's done, we now actually have a means of authenticating people that do not require usernames and passwords. So moving forward, our interactions will actually probably be more signature-based. So as an example, when you want to log into a web server, instead of using a username and password, you just simply assert who you are, and the system will look up your public key, send you a challenge encrypted with your public key, and you send the challenge decrypted back. And the only person in the world who can do that is the person who controls the private key credential. So it's a challenge response type of protocol, which is significantly more secure, and it means you never have to remember a single password. Second, if you think about social networks, currently social networks are curated by central actors. If we can actually put most of the underlying data on distributed storage systems, and we have a nice web of reputation, a nice identity space, then actually you can create invitation-only dark social networks where all of the data is actually encrypted, and the only people who have access are trust circles. And again, you'll actually have the ability to revoke certain people's access to the data that you've shared with them via things like OMS. All the communication can then be end-to-end encrypted as well, because every single party is identifiable uniquely, has a reputation, and also has cryptographic credentials. So you can get rid of man-in-the-middle attacks, and you don't require certificates or things like that. And so this could actually mean the end of domain name systems as we know it and public key infrastructure as we know it, which is tremendously exciting. I would recommend anybody listening to this lecture to actually read John Clippinger's Self-Sovereign Identity Management essay. It's actually in the book From Bitcoin to Burning Man. I believe it's chapter 2. And it talks a little bit about where controlling one's identity can lead and the types of interactions we can have. It's a very exciting field. So this is really the first major component that these three pillars enable. An even more exciting component is the notion of a single global marketplace. And so if we really have a secure, immutable place to store product and service offerings alongside a decentralized currency, well, isn't there any reason why we can't implement a great marketplace that, just like a blockchain, can't be censored or disrupted? So the products or services that you offer, whether they're legal or not, can't be removed. They can't be taken down, even if they're inconvenient to certain actors. So there's projects like OpenBazaar, for example, that are leading the way and trying to figure out how to create a decentralized, censorship-resistant marketplace, and are also exploring how to build reputation systems so that there's an economic cost to fraud in the system. In many cases, that will be greater than the value gained from committing fraud, which is always the key in creating a secure marketplace. If you think about eBay's seller ratings. Now, if we use smart contracts in private law, another really cool thing happens. And let's have a brief aside about private law. It's nothing new. It's been around for quite some time. During the Middle Ages, there was a system called Lex Mercatoria, which merchants used. If you were a merchant and you traveled between country to country, it didn't make a lot of sense to try to understand the legal system of every single place you went. For disputes, merchants would rather have a single legal system, whether they were in Florence or in Amsterdam or in Paris, that they could leverage and use so that they'd have a consistent amount of certainty in their trade. Well, the modern day analogy for this is maritime law, and there's systems like Unidroit which are trying to go ahead and create an international global framework of private legal relationships. And if we can do this and combine it with smart contracts, then actually what we can do is create an automated global legal system that's basically object-oriented, it's very efficient, and it actually applies the same way no matter where we're at in the world. All right. So another thing that's really exciting is the prediction markets. Systems like Augur, for example, where it's one thing to go ahead and try to sell a product. It's another thing to try to determine what the price of a product should be, or what the likeliness of an event should be. Or let's say you have a one-of-the-kind product, like a rare painting, like the Mona Lisa, and you're trying to determine what is the value of that particular Mona Lisa. Or maybe you're trying to incentivize certain types of behavior. Or maybe you're trying to get information that's external to your network, like who won a sports game, something Bitcoin can't really know, but you're trying to get that into the system. But you're trying to do it in a way that's as trustless as possible, or at least the level of trust is known and quantifiable. So projects like Augur and other prediction market systems are attempting to integrate this in a way that is as decentralized as possible. And then finally, we have kind of the gray or dark area of marketplaces, and we have a project called Dark Leaks, which actually allows people to sell information like state secrets, like classified information, or source code, like Windows source code, for example. Or perhaps you found an exploit in a software system and you want to share that. Or maybe you have personal information like nude celebrity photos. It turns out that people have found a way to allow you to sell this online anonymously in a completely decentralized format. So really, it's actually kind of amazing. We can create this huge global marketplace that's totally censorship resistant. You can sell literally any product or service. You have controls and mechanisms to ensure that this is done safely. And it's not an absolute. It's actually more of a spectrum where you can live on the dark leak side. And if you're okay with doing business in those black markets and gray markets, that's fine. Or you can go all the way up to an actual formal, highly contracted, publicly auditable transaction. Perhaps you're buying a computer and it's just like it was on eBay, but instead of having eBay control, as OpenBazaar does. And you can even price one-of-a-kind things or events or predict who's going to win an election and actually have values connected to that. So this is the second thing that Programmable Society should have and is enabled by the three pillars that I mentioned. Finally, I think the most emergent and the farthest out, but I think the most exciting overall, is the whole idea of algorithmic governance. So the same mechanics that actually permit decentralized commerce and censorship resistance can actually enable corruption-proof elections, transparent accounting, and even autonomous companies. So many people may have heard the term triple entry accounting, or you may have heard the idea of a CINA-compliant election. It stands for confidentiality, integrity, non-repudiation, and authentication. In all cases, this is basically saying, listen, we can take blockchains and this programmable smart behavior, and so we now have a situation where the rules are defined and absolute and trustless, and that all of the results of things, the data that we receive, can't be taken down, and we know it hasn't been tampered with, and take these things together alongside the fact that we now can have a very mesh-like architecture for the way we relay information to each other. So major ISPs can't censor things. You can't have a situation like occurred in Egypt where the entire internet was shut off. You actually now have a much more resilient backbone. And you can combine that with ideas that have come out of the liquid democracy, the liquid feedback world. You can take that ideas that have come out of Estonia with the Estonia project, and all of a sudden now you actually have totally transparent voting, and you have rapid opinion polling. You have the ability to very quickly decide who gets to be leader or what decision is proper, as long as the mechanics behind that election are well understood. The other thing is that conducts of leaders can actually be constrained algorithmically, including the locking of assets and smart property. So if the government or the company's assets are digital and they have a constitution, if somebody who's leading the company decides to go spend the money on something they're not allowed to spend, the constituents can actually lock that. So to use an example, imagine if the US government's assets were digital and they decided to go invade Iraq. One of the things that could be done if it was algorithmically constrained is that the American population could vote and lock the U.S. government's money. So it wouldn't actually be able to pay for the adventure to Iraq, and they'd actually have to convince the voters that this was in some way legal. So this is an example of where you can go once your assets become algorithmically constrained, and your behavior of your leaders are actually constrained by algorithms. In fact, companies themselves can be constructs of code and modularized. There's this wonderful term called a DAO. Stan Larimer calls it a DAC, and they basically stand for a decentralized autonomous organization or a decentralized autonomous company. And the basic notion is that you have stakeholders who create a constitution, and they have some form of decision rights, and then they elect certain actors, because we don't have quite strong AI yet to be these actors, to preside over some pool of assets and make decisions about how that system should run. And in some cases, the actors can be totally automated. So Stan and others argue that Bitcoin is an example of this. In other cases, they can be semi-automated, and strong controls can be placed over their behavior. And that relies on the fact if the organization requires human judgment or not. And one thing that's really cool about this that I personally like is the whole idea of an open source project having its own currency and treasury. So the BitShares project in particular has begun to explore this, where developers in the BitShares ecosystem are now actually starting to be paid by the blockchain itself. Via an inflation mechanic, delegates can actually be elected from stakeholders, and the inflation can actually pay the developers. So instead of working for a company like Blockstream or the Bitcoin Foundation or BitPay and altruistically contributing to an open source project on your spare time, or working for some highly organized open source project like the Linux Foundation, which is paid for by a federation of companies, you now can actually directly work for the technology stack that you happen to be implementing. And there's no reason why this couldn't actually be done with other systems. For example, 0MQ or Linux. All these things could actually be tokenized. The market could produce a value for it, and then the developers themselves could actually be paid to work for the open source project. So there's no conflict of interest. And if the project becomes very large and very valuable, the system would actually have enough money to do more than just pay for its own development. It could actually pay for marketing and evangelism, venture capital. You can even imagine a blockchain owning things. For example, shares in other companies or assets in other blockchains. The sky's really the limit. And this is why algorithmic governance is kind of the most emergent, because as everything else in the space evolves, all of these properties tend to go into play. Okay, so really the overriding theme is we have pillars, And those pillars have enabled three things that I think are really exciting about where Bitcoin is going and the ecosystem as a whole is going. But I think the most important thing to take away from this is that everything here is completely open source. All the foundations of a new society are basically being laid, and now a cell phone can be a government, an ISP, an exchange, a bank, a lawyer. Well, a cell phone runs software. So really, you, the listener, are actually in complete control over where the space goes. You can choose the classes of problems you want to solve, the problems of society that you think are a big issue, and simply go out. You should ask, how should the world change? And guess what? It's your turn. You get to build it. All right. Well, thank you very much for listening. I know this was quite brief, and I hope this got everybody listening thinking about where we can go with this technology, and I'd love to get some questions from you. Have a wonderful day, and thanks for listening.
Thanks for listening to this episode of Let's Talk Bitcoin. Today's show receives support from CryptoKit.com, Shapeshift.io, and FoldingCoin.net, where you mine medicine, not hashes. Today's magic word is evolve. That's E-V-O-L-V-E. Once again, evolve, as in evolution, E-V-O-L-V-E. Evolve. You've got until the 10th of March to visit letstalkbitcoin.com and the Let's Talk Bitcoin iOS app and enter it for your share of the listener rewards. Content for today's episode was provided by Charles Hoskinson. Music for today's show was provided by Jared Rubens with the LTB theme song. This episode was barely edited by Adam B. Levine, and if you'd like to see today's presentation with the accompanying slides, head to letstalkbitcoin.com, and in the episode show notes you'll find the presentation embedded. Thanks for listening.